And this is our third in a series of plotting hyperbolas in Desmos. And so we're going to be using the same hyperbola that we used in the last video. And just like we started the last video, we're going to turn off but not delete all of these points and line segments that we plotted. So we're turning them off, but we're not deleting them because we're going to be using them. We're also going to turn off the labels, which means that we can uncheck the check boxes. There we go. Okay, so we've got this nice clean version. Let's just zoom out just slightly. There we go. So there was our hyperbola. And so we're going to make a change here. Okay, in the last video, we swapped the positions of the 3600 and the 121. The 121 was originally underneath the x squared, and the 3600 was originally under the y squared. So in the last video, we swapped their positions. Okay, in this video, what we're going to do is we're going to put a plus sign between the x squared and the y squared, and oops, for just a moment there, we have an ellipse. And then we're going to put a minus sign in front of the y squared, x squared rather. Okay, and look what happened. Okay, what actually happened was that instead of opening horizontally, like the previous hyperbola, now this hyperbola opens vertically. Okay, so there's somewhat of a change here. Okay, so again, let me go back. So when the y squared term is negative, the hyperbola opens horizontally. But when the y squared term is positive and the x squared term is negative, the hyperbola opens vertically. Good thing to remember. Okay, and so now the next thing that we're going to do is we're going to plot our points again. And we notice that when we click on these points, those are our vertices, 0, 11 and 0, -11. So in reality, we see those points over here. We have 0, 11 and 0, -11, but we know that they are vertices, not co-vertices. So all we have to do here is get rid of the co, and there we have a vertex labeled. And so let's turn those points on. There we go. So that was simple, right? That was a simple transition from the previous hyperbola. Okay, and then notice that our vertices are 0, 11 and 0, -11, and the line segment that joins those vertices is the transverse axis. And we've plotted that here with our polygon function, and it's good to go. So all we need to do is turn it on, and there's our transverse axis. That's great. Okay, now our conjugate axis is going to be based on the number 3600. The square root of that is 60. So we have those numbers here already. So these points turn into co-vertices. So there's the first, whoops. Try that again, co-vertex. Okay, so let me label this one also, co-vertex. There we go. And they're labeled, so let's turn them on. So there are our co-vertices. Notice, please, that the co-vertices are always between the two branches of the hyperbola. Okay, the vertices are always on the hyperbola. Okay, but the co-vertices are always between the branches of the hyperbola. Now, in various sciences, we use hyperbolas to describe things or explain things. One branch of science that uses hyperbolas is astronomy. Okay, and in astronomy, planets move along the branches. Planets can move, planets or moons or stars or whatever, comets can move along the hyperbola. And then when they get to this point, notice notice that in moving here toward the right, okay, it's also decreasing its elevation. But then once it gets to the vertex and passes, whoops, I'm going to go over here. Once it gets past the vertex, it starts increasing its elevation again. So that point, the vertex, in astronomy is called a turning point. Okay, that's called a turning point for the orbiting object that happens to be traveling along a hyperbolic orbit. So these things do have uses in the real world. Okay, so we plotted our covertices, which are between the branches of the hyperbola. We want to plot our conjugate axis. Now our conjugate axis is going to join those two segments together. We've already written the polygon, so all we have to do is turn it on. And there is our conjugate axis. All right, now as far as the points are concerned, we are going to have well, let's see how those work. Again, we have 60, negative 11. That's good. Then 60, 11. That's good as well. Whoops. There we go. All right. And then we have negative 60, 11. No, that's not what I wanted. Excuse me. Okay, I wanted 60. Actually, I want to put this up here. Sorry about that, guys. Okay, so our first point was 60, 11. Our next point was 60, negative 11. Okay, and then we have negative 60, 11, and negative 60, negative 11. Now, let's see if we have to change any of these and the order of them. Let's just turn on the polygon. And no, we don't. We don't have to change any of them because we have our box. Once again, okay, now remember, whoops. Go turn that on. And if we click and hold, we can get into the edit box, and we see that it's blue and it's checked. We could change that, of course, but we don't want to in this case. Okay, so now we're going to check on our asymptotes. Let's just turn this one on and see what we get. And it's perfect, the perfect asymptote. It goes through the lower left corner of the X box and the upper right corner of the X box. So that is exactly what we need. And if we turn on the other asymptote, same thing. It goes from the upper left corner of the X box down through the lower right corner of the X box. So our asymptotes are perfect also. Okay, now the only thing that we're really going to need to change drastically, other than just changing some labels here, are the foci. Okay, now the foci, as I mentioned in the previous video, the foci are always on the same line as the vertices. In this case, the vertices are on the y-axis, which means that the foci have to be on the y-axis also. So to get these foci, now we're going to use the same two numbers that we used before, but to get the foci, we're going to have to swap the order of those two coordinates. So we're going to have 0 first and then 61. So 0, 61 is our first foci, or focus. Focus is singular. So let's change the label. It'll be 0, 61. There we go. Okay, and let's plot that point. So there's our focus. Okay, now we said that in the previous example when the, what did I say in the previous one? Okay, now, yes, now notice that the focus is far away from the square root of 121. Okay, so remember that this is based on our original Pythagorean triple, 11, 60, 61. And so in this case, the focus, which is based on the numbers, the highest number in the Pythagorean triple, that is the farthest away from the vertex. So 61 is far away from 11. Okay, and then we're going to change the order for the other focus. It'll be 0, negative 61. And let's change our label as well. That's going to be 0, oops, there we go, 0, -61. And that is it. Okay, and so let's plot that point as well. So we plotted and labeled the foci as well. Okay, so we have our vertices. In this case, the hyperbola opens vertically. That's because the y-squared term is positive and the x-squared term is negative. Whenever the x-squared term is negative and the y-squared term is positive, the hyperbola opens vertically. The foci are always in the same direction as the direction of opening. So since this hyperbola opens upward, there's going to be a focus above the hyperbola, and the other branch of the hyperbola opens downward, so there's going to be a focus below the hyperbola. And so we plotted the foci correctly, and then the co-vertices we plotted correctly. Remember, the purpose of plotting the co-vertices and the conjugate axis here and the transverse axis is to help us make that X box so that we can appropriately plot the asymptotes, because we want to appropriately plot the asymptotes whenever we plot a hyperbola. So hopefully this again was helpful to you, and we will make some more of these videos dealing with conic sections and the cool things that we can do with Desmos in mathematics.